Okay, hi everyone again. So this time we're going to learn how to solve this one. But before that, we're going to discuss some of the basic concepts regarding the set operation, union, intersection, and about the complement of a set. Okay. So suppose we have given the following sets. Say for example, we have U, universal set. The given, okay, we have 1, 2, 3, 4, 5. And for the set A, the given are, let's say, 1, 2, and then 3. For set B, let's have the elements for set B are, for example, we have 1 and then 4. So how are we going now to find for the, to look for the union of these two sets? When we say union of two sets, the union, the elements are common to both of the two given sets. Elements of A and elements of B. The commonality element of these two sets. For example, we have set A and set B. The common members of this set is what? We have 1 is common. Okay, only 1 is common to both sets. 1 is a member of A. At the same time, it is also member of set B. So therefore, A intersection B, we have 1 as only one element. So, but the in this one, in this intersection, we can have many members depending upon the given. Take note that the elements are common to both A and B. So A intersection B. So how are we going now to show this one in Venn diagram? Through that, we're going to have this one. So since there is an intersection, the two circles coincide each other. We have the two circles intersect to each other. So we have set A, set B. The circle intersected. So the circles rather are intersected. Now letter A, set A, and set B. The common element is 1. 1 is a member of set A, at the same time member of set B. So this time, what are the elements? Set A, we have 1, 2, 3. 1 is there. We have 2 and then 3. Set B, 1 and then 4. Oh, 5 is not part of A and not part of B. Therefore, 5 is outside of the two groups. Outside of the two sets, we have 5. Outside of the two circles. So here, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The first 5 natural numbers. So this time, how are we going to show this in Venn diagram? To show that, you must shade the region where you must share the region where the elements of the intersection is found. So it is here, 1. It is placed here. That is the intersection of A and then B. Let's have now this time. How are we going to find the union? Union is A, union B. So, how are we going to obtain the elements of A union B? When we say union, the elements of A and B, or both A and B. So, you're going to combine all the elements, all the members of set A and set B. So, we have this one. We have 1, 2, 3. For set B, we have 1. Is there 1 and then 4? So, it is now the union of A and then B. 1, 2, 3, 4. So, how are we going now to show this in the Venn diagram? To do that, the same process. Let's make a Venn diagram. Okay. So, for us to not to confuse, let us label this is A, this one, and this is A union B. Okay. We have the same process, universal set. We have these two circles. Okay. Union of A and B. Set A, set B. So we have set A. The same, we have 1 is the common element of those two sets. 2, 3, 4, 5. Okay. To show this in Venn diagram, we have to shade again the region or the portion where these elements are found. So we have 1, 2, 3, 4. So these two circles will be shaded. The elements of the shaded part are the elements of the union of two sets. Set A, union B. Let's have now the complement of the set. We have B. Okay, we are going to find the complement of B. For example, how are we going to find the complement of B? When we say complement of B, the set or the elements of set B complement are the elements in universal set but not present in B, set B. We have, or not found in B, but found in universal set. So we have B is 1, 4. So 1, 4 ang nasa B. So 1, 4 is in B. Therefore, not part of B is 2, 3, 5. We have 2, 3, 5. It is not part of B, but still it is this. But still these are the members of universal set. So we have to have a Venn diagram. We have this one. The B complement. We have set A. Since there are two given sets, the same process. Universal set. We have A, we have B. So same, 1, 2, 3, 4. In set B is 1, 4, and then yung 5 is not part of the two groups. It is outside of the two sets. So this time, the same they looks the same, but they will be different on the way we shade depending upon the given. So here the shaded part is intersection, this one the union, and this one B complement. So not members of B, but still under universal set. We have to shade the region where the members are not part of B. Members not included in set B, we have 2, 3, 5. Shade this region. Okay. Oh, we have now 1, 4. Set B. Okay, the set B complement is the shaded part. 2, 3, 5. And 1, 4 is set B. 1, 4 is part of the B, and not part of B is 2, 3, 5. Not members of this group. But still, it is under universal set. Okay, that's how we show in Venn diagram. That's how we find the union, intersection, and complement of the given sets. Let us now answer this one. Okay. Example, we're going to answer this activity. How are we going to find this 3? So in this given universal set, we have A, B, C, D. We have set A, the elements are A, B. For set B, the elements are B, C, D. So to do that, let us now observe. We have A intersection B. The common elements of set A and set B. Meaning, the elements member of B at the same time members of set A. We have A is not found. B is in A, and B is also in set B. this only one element is common. So we have the answer will be set B. We found out that the intersection of A and B is simply B. For number 2, the union of two sets, the elements in A and then in B, or both. Combining all the elements of A and elements of B. So we have this one. We have A, B, C, D. That is the union of the two sets. For number 3, we have A intersection B. Complement. The complement of A intersection B. As you can see now, that not part of this group of A intersection B, not found in this set, but still present in universal set. How are we going to look now? So we have A intersection B, the element is set B, meaning not part of this group will be A, C, D, because B is part of the intersection of two sets. Complement niya, the complement of this one is simply, we have A, C, D. We have A, C, D. Okay, for us to understand, let us first draw this one in Venn diagram for let number 3 to make it for us clearer. So we have set A. We have this one, universal set. We have set A again, and set B. And set A, the intersection of set A and B are, we have B, small letter B. For set A, the elements are A, B. It has only two members, so we have A and then B. A, B are the elements of set A, and A is not part of this one. So we have set B, the elements are B, C, D. Check now, we have B, C, D, B, C, D. We have set A, B. So this time, the intersection is set B. So therefore, the complement of the intersection is outside of set B. This now the complement of the intersection. The shaded portion, it is where the elements are found. We have A, correct. C, we have D. Not part of A union B. Outside of this one. That is now the complement of A union B. The answer is A, C, D. Let us now have the next the letter B. The given now, as you can see now here, the given is not in Rooster method, but it is written in set builder notation. We have universal set. Set of all x element of say exponent or positive. This one is pertaining to set of all positive integers. -4 ay such that x is less than or equal to 8 but more than -4. So based from the given, say plus, that is now positive integers. Therefore, in this set, we're going to disregard 0 and negative integers. Just focus on positive integers or counting numbers. So we have, but the condition is it must be less than or equal to 8. Therefore, 8 is included. We have 8. So we have now 8, 7, 6, 5, 4, 3, 2, 1. These are the possible elements of this universal set. For set A, we have x is what? X is less than or equal to 6, but more than or equal to 4, pertaining to integers. We have Z, set of all integers from that is more than or equal to 4, from 4 up to 6. So we have here the elements will be 4, 5, 6 for set A. For set B, the possible elements for set B are, we have set of, again, positive integers. So we have negative, the value of x is less than 6. Let's begin from 5, 4, 3, 2, 1. So it is now these are the elements for the set B. Negative 3, negative 2, even though negative 2 is less than 6, but this, we have this symbol, positive integers. Select only the positive numbers, positive integers. So these are now the elements found in this given set. How are we going now to look for A union B? So combine the elements of A and the elements of B. So we have A union B. What are those? What A and B? We have 1, 2, 3, 4, 5, 6. So elements of A, combining all the elements, we have 1, 2, 3, 4, 5, 6. Okay. We have 1 to 5. 1, 2, 3, 4, 5. 4, 5, 6 is also there. Combining them, write them as 1. When you see that there are two elements, just write them as 1. There are 2, 4. Write them as 1. We have 1, 2, 3, 4, 5, 6, the members of A union B. For the A intersection B, what are the intersection B? What are the elements in the intersection B? We have A and then B. The common elements of these two sets, meaning members of A, at the same time, they are also members of B. Let us now trace. We have 4 is in B and 4 is in A. At the same time, 5 is in B and 5 is in A. Therefore, we have two elements, 4, 5. We have 4 and then 5. These are the elements of A intersection B. So how are we going now to find for this one? The complement of A intersection B. So to do that, meaning it is not part of the intersection of two sets, but part of universal set. So not part of this one, but part of universal set. So we have here 4, 5, 6 is part, therefore not from the universal set. 4, 5, 6. These are excluded. Therefore now what remain are, we have 1, 2, 3. We have 7. We have 8. 1, 2, 3, 7, 8. So 4 and 5 is in intersection. So 1, 2, 3, 4, 7, 8 is the answer. Let us now show in Venn diagram. How are we going to show this in Venn diagram? To do that, let's now have this one. Okay. We have set A, and then since there are intersection, we have to intersect these circles. We have 4, 5 is the intersection. 4, 5. Set A and set B. Members of A, at the same time, they are also members of B. So what are the other elements? We have set A, we have 4, 5, and then 6. We have 6. For set B, we have set B natin, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. For the universal set, we have this one. So, we have U, 1 up to 8. The first 8 natural numbers, 1 to 8. So, we have 1, 2, 3, 4, 5, 6. So, 7 and 8 is not part of the two groups. These are outside of these two sets. So, how are we going to show this in Venn diagram? So, let us now shade. So, this one, A intersection B. This one. We have to shade all the regions where this 4 and 5 is found. So, we have now this one. This is the complement of the intersection of the two sets. The region, the elements are found in this region. So check now, we have 1, 2, 3, 7, 8. 1, 2, 3, 7, 8. Okay. By the way, we forgot the 6 here. There must be 6. 1, 2, 3, 6, 7, and then we have 8. That is okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay. The correct answer for A, the complement of A intersection B is 1, 2, 3, 6, 7, 8. 1, 2, 3, 6, 7, 8. This is now the answer for these questions. Okay. Thank you very much, and I hope you learned something about this lesson. Okay. But later on, we'll discuss about the solving word problems involving set operation. Okay, thank you very much.